Hello, it's me, and as promised, I'm going to do a demonstration slash little tutorial on this puzzle, which is the Super X. So what is the Super X? Well, the Super X is all the fun and simplicity of a dino cube, which is a corner turning puzzle, and the addition of the face turning capacity, which is a 2x2. Now, the 2x2 is among the more simple of the face turning puzzle solves, and of course the dino puzzle is kind of a neat little thing, but doesn't add too much of a challenge just because of the limitations of the scramble. But put it both together and it does make for something of an interesting scramble. Now this particular one is held together by magnets. There's another one that's got a different design from Tom Z. It's pretty good. I'm not a big fan of the magnets, to be honest with you. When I first started trying to play around with this, it would just keep crumbling, and that's because I wasn't holding it quite right. You can see the stability is very good, and it's actually kind of a neat little mechanism. The only issue is when it comes to the dino moves, which are these. You can see it starts to pull this out a little bit. A couple times the magnets would come out and I had to super glue them, but you can see you can do dino moves and continue the scramble with 2x2 moves. And I'll tell you that the challenge of this goes beyond just a simple dino to 2x2. So I'm going to kind of go through that because the technique that I'm going to use with this is going to enter into possible strategies for future puzzles. This puzzle, I believe, should be mass-produced because it's a lot of fun. It adds to the challenge. Not as a magnet, though. Kind of an interesting mechanism, but I think using Tom's mechanism to keep it held together would be best. But looking at this, again, as long as I hold it okay, then it's very stable, especially with the 2x2 moves. I'll post links as to where... Actually, I don't know if you can pick this up on Shapeways now. There's other variations of 2x2 hybrids that you can pick up that I'll show. Now that we've done that, you can see you have the typical corners. We're now about to destroy the corners by doing dino moves. So I'm going to move this over here, and now by doing 2x2 moves on top of this, I'm now causing a huge and critical disruption in the organization of this puzzle. But fear not, there's a strategy to this. Turn this over here, here. So, once you get used to how to hold it and how to turn it, it actually is okay with only an occasional popping. See, this one is about to pop on me right now. But if I reposition and don't panic, then we're okay. This guy's about to pop as well. Otherwise, I have to say it is kind of an ingenious mechanism. So, much respect. Turn. So I'm going to keep doing this. And in the interest of keeping tradition going, Alakazam. Okay, there we go. A nice challenging puzzle. It's a heavy one too. Now, when demonstrating puzzles that aren't mass-produced and are generally difficult to find, I don't go into quite as much detail as I would with a straight tutorial, just because, well, more than likely you're not going to find a puzzle that's quite like this. But there is an overall strategy that's worth kind of getting into. When dealing with the dino to hybrid combination, whether it's this or the dino's cube or something of that nature, what I like to do is I like to reduce it to dino cuts, because when I do dino cuts, I can isolate it from other dino cuts. So what I'm going to do is I'm actually going to pick 4 different dino cuts and kind of reduce it down into dino slices. Kind of like the 4x4 AI cube, where you did 2x2 segments and reduced it that way, or the parity-free solve of a 4x4. But if I take a look at this dino cut over here, let's say reduce it to a dino cut here, and then maybe reduce it to another dino cut here, because these two don't run into each other. And then in addition, I can reduce it to a dino cut here and here. So that way, in order to solve this, if I do that, then I can put in the other corners. So when I say a dino cut, what that's going to consist of is it's actually going to consist of a true 2x2x2 corner made up of these 3 edges, as well as portions of a 2x2 corner that move along with it. So by reducing it down to a dino, I have to reduce a corner appropriately, which means I'm reducing 4 2x2 corners. So let me demonstrate what the heck I'm talking about, because I even confused myself. So what I'm going to do is I'm going to start off with a green side. So here's a green and red. What I'm going to do is a combination of 2x2 strategies and dino strategies in order to move things in. But before I do this, I should probably back up a step just to describe a little bit more the reasoning of what I'm doing. To do this, all you need to know, aside from 2x2 algorithms, are two basic algorithms of moving corners around. There's no centers, there's no edges or anything like that, so all I need are 2x2 algorithms. The first one is the standard edge corner swap. With this, I have a way of cleanly swapping these two corners. Well, that's not exactly what happens, because you know, according to the law of cubes, you can't cleanly swap. What that does do is it takes this corner, puts it here, and this here. So these two move together here. This moves here, so if I move it back to here, it looks like I cleanly swapped it. And that's 2r u, 2r ui, 2r, turn counterclockwise, 2r ui, 2r u, 2r. And then inevitably turn this back. Once I turn it back, you can see this appears to be a clean swap. That's going to be used when I have to reposition this, because as I put the corners in, which are the center corners of my dino slices, I don't want to change the configuration of anything. 2r u, 2r ui, 2r, 2r ui, 2r u, 2r. Now, I also want to bring up an old friend. One of the simplest of commutators that you see me use a lot, especially when it comes to placing corners, whether it's the first layer or the last layer, and that's RIDIRD. Now it's worth noting what's happening with this. Have you ever wondered why doing RIDIRD all around a puzzle solves it? Seems kind of magical, actually. So let's say I swap this down and up, RIDIRD, RIDIRD. So I only did it once. Move it over here, RIDIRD, RIDIRD. That's one set. Do it again, RIDIRD, RIDIRD. That's two sets. Two sets brought it back. So the total amount of RIDIRDing that had to be done is 3. Each set is doing it twice. RIDIRD, RIDIRD. It's swap down and up. Swap down and up 3 times, basically, and you'll end up moving it back. So let's say we wanted to do it over here. RIDIRD, RIDIRD. Okay, that's once, RIDIRD, RIDIRD. That's twice. Move it here, do this, RIDIRD, RIDIRD. That's 3 times. So 3 RIDIRDs total managed to get everything back. RIDIRD, RIDIRD once, RIDIRD, RIDIRD twice, RIDIRD, RIDIRD 3 times. So even if you did one thing and you did it 3 times, the first set, the first time you do it, down and up, this will flip down across and back. But this will be rotated wrong, this will be rotated wrong. The second time, it'll be rotated again, and these will be rotated again. So it takes 3 rotations. This can rotate here, rotate once, twice, and 3 times. So each one rotates it 3 times as it brings it down and back up. This also rotates it 3 times as you bring it across and back. What all this means is that if I wanted to rotate this, I can go RIDIRD, it'll rotate it, but it's going to mess this up. So if I wanted to bring this back, I have to RIDIRD something here 2 more times. And if I don't want it to be this one, well then I can just move to this one, RIDIRD this one if I don't care about the orientation, and I can get this back. So that gives a little bit more detail, and I'm going to use that concept in how to solve this. So I'm going to refer to that again. But let's see how we're going to do this. Well, I'm going to start off with the green side. Here's a green and red. So I'm going to do dino moves to put another green side in here. It can't be the other green and red because I'm not going to get a corner like that. It's got to be a green and any other color. So we're completely free. Well, not exactly any color. It can't be a green and orange because red and orange have to be opposite each other. If I do a green and orange here, then I'm going to say those 2 sides are right next to each other. So it can be, say, a green and gray. Well, here's a green and gray here. So I'm going to do a 2x2 move to bring this here. Then a dino move. Well, here it is over here. A dino move to move this in place. And let's see if this moves in, and obviously it doesn't. It's opposite. So I'm going to move this one in and see if this one works. Well, this one doesn't work either. So if this green and gray doesn't work, this green and gray must. So I'm going to move this down here And I'll take this and dino this up, and there it is. So I've got the two greens, I got a gray and a red. The other slice that goes here has to be red and gray. Now I've got two to choose from. The one that it's going to be, well, let's see if it's this one. This is conveniently placed. If this were anywhere else, I just do face turning moves to move it in place, move it in, and you can see, bang. So this is correct. So I have my first corner, 2x2 corner here, but this also acts as the center point of a dino turn. So by turning this, I can just rotate this guy around like so. Okay, what I'm going to do now is I'm going to put my next corner not next to it, but across from it, because if I do that, then I can move dino turns without affecting this side here. So it's going to be a 3-layer side, or it's going to be a green side rather, because this whole thing is now going to be green. Could I use this? And the answer is, well, no, I can't, because this is green and gray. I've already got a green and gray here, which means this will be the gray side, so I can't have this being the gray side. So it can be anything except green and gray or green and red. So which one should it be? Well, here's green and orange. Let's move this in and see what we can make of that. Can't be green and red. So I'm RIDing this basically. And put it over here. Okay, so could I use green and orange? Well, I got to be careful because there's two green and oranges. Could I use this one? And the answer is no, because this is going to be my red side. Orange is supposed to be opposite red over here. The way I've got this is that if I keep this here and I assemble this, I'm going to end up with the orange side here and the red side here. So this organization is very important because if you do it wrong, you're going to assemble a bunch of really nice looking 2x2 corners, but you won't be able to solve with that. It won't make any sense. You'll have impossible parities. You'll assemble pieces that are mirror images of each other. Sometimes you'll assemble two pieces that look just like this, and you can't really solve it as a puzzle. So this is the wrong green and orange. So I'm going to find the other green and orange, which is right here. Let's move this down. And now let's move this guy up. Turn, 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 bang, zoom, splat. Do we like this? We do, because orange is here to be opposite red. So this is going to be the focal point of how I'm going to assemble this. So what's going to go next to this is going to be another green, but in this case it's going to be the one that's opposite silver, which is yellow in this case. So the green and yellow one is going to be the opposite one here. So which one is the green and yellow? It looks like I have a couple to choose from. Here's a green and yellow. Here's one over here too. Let's see if we got lucky and see if this one makes sense. So I'm going to move this here so it's out of the way of this one that I just made. Put a dino move right here. And see if this green and yellow can come into here. And as you can see, when I move it, it's the wrong one. It's the wrong one because this doesn't face that. So it must be this green and yellow here. So I'm just going to move this down, bring this back up, put this in position, and without collapsing the puzzle under my fingers, try to make a turn, bang. So this is good here. So now I'm just going to dino this back up. Okay. So now I'm going to put in this final one here, which is going to be yellow and orange. And you can see it makes sense with these portions here. So where's my yellow and orange? Yellow and orange. Here's one over here. There's going to be two to choose from. So let's move this down first. Position it here. Dino turn it here. So now this comes into here. Turn it, and in we go. So here we have the first two 2x2 corners, and I know that it's placed correctly. This is going to be the green side, orange opposite red, yellow opposite gray. So now what do we do? Well, I want to place the next corner in another dino position that doesn't interfere or cut into these dino slices. So the next one then would be over here. This dino slice, if this is in the center, does not cut into any of these dino slices. So I can move it freely without destroying these. So what I'm looking for is one that has an orange portion with it, because this will be the orange side, this will be the green side, this will be the gray side. So I'm actually looking for an orange and a gray. Well, here's an orange and a gray slice. Is it the right one? I turn it here and happily find that it is. This fits here, this fits here. I easily could have had the wrong orange and gray slice, and what I would find is that perhaps the gray is here. Well, the gray would be here and the orange would be here, so I know that that's not the right one. This one happens to be the correct one. So now it's a matter of moving the rest in. So let's say this piece is going to be orange, and what is this color? It's going to be the one that's opposite green, which in most color schemes is blue. So really what I'm looking for is orange and blue. Here's an orange and blue over here. Now let's kind of calculate to see if this actually is going to be the right one. If this were to move over here, this would occupy this spot over here. So we're going to imagine the blue is here and the orange is here. Turning it up again, the orange would come up to here and the blue would be here. So this is the correct one. I need to get this over to here. Let's get this down to here so I can move it in. Well, how am I going to do that? I don't want to destroy these quite yet. So I'm going to go ahead and do an adjacent corner swap to make that happen. I'm going to hold it over here, and by the end of it, these two will swap. And that's going to be 2R U, 2R UI, 2R, turn it counterclockwise 90 degrees, 2R UI, 2R U, 2R, and then bring it back here. All right, taking stock of what we have, notice it didn't change any of these. We're trying to move this into position, and we've got this properly positioned. So now I'm free to do dino moves without messing up any of these moves here. The interesting thing, or the fun thing about the solve, is you can get very confused very quickly. Multiple colors, some that look like each other, some that are sort of equivalent but not, make it a little confusing. So orange and blue is right over here. So all I have to do is move this in. I'm going to cause an issue with this area here. So let's do this. Let's move this down. And now we can take this down here, this dino slice down, which puts this out temporarily. Then I turn this dino slice up and bring it in. It's just position and reposition. So this is fine, and I've got this okay over here. Now for here, to fill this in, I need the gray and blue, which is this. Well, which one? It's not this one, because if I move it up, the blue is going to be here. It's this one. So I'm just going to dino turn this into the right position, like so, and now this can come up. I'm going to end up causing issues there, so why don't I do this? Same thing. Move this down without destroying it. Put it in position and cleanly move it up. Bang. Okay, so without too much effort or messy cleanup, sort of, I got this in place. So these are well positioned and this is well positioned. I have one final corner 2x2 segment to place, the center of a dino, which is over here, because this one doesn't come into conflict with any of these. So let's see how we're going to do with this. This, conveniently, I have the red and the yellow already in position. Got lucky that time. If I didn't, it's really just a matter of finding it here and placing it. Say if it was over here, what I do is I do a corner swap. Or if it was over here, I do a corner swap. If it was over here, then I would move it to here and do a corner swap and move it back. So really, I can corner swap anything around in order to put it in position, but it's already in position. So for example, if it just happened to be here, I'd want to swap this down to here. So I'd go like 2R U, 2R UI, 2R, turn, 2R UI, 2R U, 2R. That was just to demonstrate what I have been talking about, and then this moves back up here. So Okay, so picking up from here, I need the red, and it's got to be red and blue. So where's a good red and blue? Good red and blue is right over here. Do I need another red and blue? Well, there's a red and blue over here too. So which one is it? Well, let's kind of calculate which one it might actually be. So is it this one? Well, I'm picturing this one will end up here if it were to come over to here. So we'd have red over here, which would then go here, which would then go here. So I'm going to say this is the real deal. This is what we're looking for. So I need to get this to here, which means I need to get it within an area that I can do a dino turn. And a dino turn to move this in would be bringing it over here. So let's do, well, I don't want to adjust this. I don't want to flip this. So I'm just going to manually turn it like this. Once I've done that, this can now slip into here. So we turn this like so, and that's where we want it to be. Now this got turned, but that's okay. It's not going to lose its relative place. I'm just going to turn this back. So these are still good. These haven't been destroyed. This has been turned around. Now if that freaks you out, as it does me, I don't want to destroy the position of where these are because that can lead to more confusion. So what I'm going to do is, keeping this where it is, I'm going to RID this until it comes back up. But I know what's going to happen. This is going to be messed up. Or not messed up, but it's going to be turned. So to turn it back, I'm actually going to move this to here, then RID it until this is back where it needs to be. So let's RID this, RID, RD. This is back up, and I did that with one cycle of that algorithm. I'm now going to move this in. So 2 cycles of that algorithm should put this back where it belongs. RID, RD, that's 1. RID, RD, that's 2 cycles. Move this back, and as calculated, there it is. So that's a way of using what that RID actually means to bring it back. But now I have this. So where to from here? I want the yellow and blue. I got 2 to choose from over here. So both of these yellow and blues have to come up to here somewhere in order to be moved properly into here. But which one is it? Well, like I say, I've got 2 to choose from. But let's go ahead and move this up here. And it's going to be this one. This can come down to here. If it wasn't, I just have to do some turning, and I could do RIDs to turn this down. So I'm just going to take this, turn it into position, then I'm going to move this down. Okay, at the end of the day, this is in, this is all fine, this got turned around. So let's go ahead and move this back in just because, well, I want it to look like where it needs to be. Well, actually, that shouldn't be hard. Since this dino move is not going to interfere with the other dino moves, the other corners, I can just turn this. And that's what I'll do. I'll just turn it. So now the first part of my strategy is complete. This corner and this corner are in, this corner and this corner are in. So we have like a zigzag pattern that we have here. And this is okay too.